Okay, so since we learned how to go ahead and find the area of a triangle using sine instead of always having to find the height and whatnot, we're going to go ahead and take a look at something kind of neat called the law of sines. And one of the things that is really helpful about the law of sines and the law of cosines that we're going to discover later on is that the triangle does not have to be a right triangle in order for us to go ahead and find the rest of the sides. That is that we don't have to use right triangle trig, Pythagorean theorem, and whatnot to go ahead and knock these things out. So what I want to do is that I just want to do a real quick statement right here that and show you how this works out. Okay, each one of these is a different way to go ahead and in between the equal side, when I say each one of these, this, and this are all going to give us the same answer as far as finding the area of that particular triangle. Okay, so just to show you real quick, the first formula takes advantage of these parts. Okay, so that is one way to go ahead and find an area of the triangle. The included angle will be C, and then using the sides A and B. Another way would be using angle A, okay, taking the sine of it, and then using, so that would be the included angle of the sides B and C, and both of the ones that are drawn out in purple above. And then likewise, the last one is going to go ahead and use angle B as the included angle between A and C. Okay, so all those are equivalent statements, and all of those will give us the exact same solution for the area of those triangles. So, since they are all the same, we can write it as one expanded statement that those are all going to equal the exact same thing, the area of the triangle. So, to derive the law of sines, what we're going to do is that we're going to do something kind of tricky here, is that we're going to take this extended ratio here, or I should say the extended, pardon me, equality there, and we are going to multiply the entire thing by 2 over A, B, C, like that. And so therefore, what we're going to do is that we're going to distribute it into each one of these and then see what happens from there. Okay, so when we distribute the 2 over ABC into each one of those statements, we're going to end up with this. And from here, we get to cross some stuff out. So the 2's are going to go out, the A's are going to go out, and the B's are going to go out. So we're going to end up with sine C over side C equals, 2's are going to go out, the B's are going to go out, and the C's are going to go out there, and we end up with sine A over side A, and we have the 2's go out, the A's go out, and the C's go out, and we end up with sine B over side B. So what this basically says, and this is the law of sines right here, is that anytime that we have a triangle, and we usually use this when it is when we don't have a right triangle, is that we can go ahead and use this extended ratio to solve for sides or solve for angles if need be. Okay, so that said, is that in the next video we're going to go ahead and use the law of sines in different cases, and we're also going to go ahead and explore some pitfalls of the law of sines that we got to go ahead and watch out for. So let's go ahead and I'll meet you in the next video.